Hey everyone, this is your practice exam for chapter 5 for stats. I want to show you how to find that, and hopefully you will have a copy of this up while you're going through this video, is the hope. So when you log into your shell, you're going to go to modules, and there we go. And you're going to go to chapter 5, and the practice exam for chapter 5 is right here. So what I'm going to be going through is this right here, and you can download it as a PDF if you want to. You can click here. So go ahead and have this up on your screen while you're going through this, and I'm going to assume that you have access to seeing these here. So let me go ahead and switch to my other camera. And there we go. All right, so what I did for number one was I loaded in this information into list 1 and list 2. Just a quick reminder of how to do that. You hit stat, go to edit, and you can see my list 1 is the 3, 6, 9, 12, 15 that you can see on your screen. And then here in the second list, list 2, I have the P of X. So you'll need to load that. So you may need to pause this to load that in. I then am going to go to stat, calculate. It's going to be one variable statistics. And I'm going to put in list 1 for my list, and my frequency list is going to be list 2. Let me show you how I do that. So to find list 1, it's above the number 1. So I'm going to hit second and L1, and it puts in L1 here. And for the frequency list, I'm going to do L2, second L2, and then calculate it. And for our first problem here, they want us to find the mean, and that's going to be X bar there. So 8.22 is what that is going to be. Sorry, I lost my screen here for a second. Yeah, so the mean in this case is going to be 8.22. And again, that can be found here under one variable stats. Next up for number 2, what I'm going to do is I'm going to do something very similar. And once again, I've already preloaded the data I loaded into list 3 and 4. Let me show you. See list there, you can see the 0, 1 through 4. And next to it are the probabilities loaded in. So now I'm going to run one var stats again. This is for number 2. And I'm going to go to stat, calculate, one variable statistics. And once again, I want to make it clear that I'm going to be putting in list 3 and list 4. So that's going to be above 3. So second 3, it's going to be my list 3. And second 4 is my list 4. And our standard deviation, which is what they're asking for in this case, is the 0.9165. I'm going to go to, does it say how many decimal places? It does not. So 0.9165. And that's an approximation, of course. Next up, we have number 3. Number 3, focus groups of 12 people are randomly selected to discuss products of the famous company. It is determined that the mean number in the group who recognize famous brand name is 7. Standard deviation is 0.6. So we have for number 3, we have the mean is 7 and the standard deviation is 0.6. If you remember, when it comes to usual, we have our mean, and if we go a standard deviation out and 2 standard deviations out, that's considered usual. So this would be 7.6, this would be 8.2, this would be 6.4, and then minus 0.6 again. 5.8. And for this particular problem, to be clear, our usual, this is our usual zone, 2 standard deviations away from the mean. That's 95% of the information. And so out here is the unusual. Anything bigger than 8.2 is unusual. And anything less than 5.8 is unusual. And the problem specifically says, would it be unusual to randomly select 12 people and find that greater than 10 recognize the famous brand, and 10 is way out here. So the answer is yes. It's unusual. Moving on to number 4. So moving on to number 4, like I just said. Let's do that. Suppose you buy 1 ticket for $1 out of a lottery of 1,000 tickets, where the prize for winning 1 ticket, for the one winning ticket is to be $500. What is your expected value? Well, I like setting up a table. And here, this is if we win. So if I'm playing this game and I win $499 because it cost me $1 to go in. If I lose, I'm out a negative $1. The probability of winning is 1 out of 1,000. Probability of losing, 999 times out of 1,000. I'm going to multiply across. This gives me 499 over 1,000. This gives me a negative 999 over 1,000. Now I'm going to add those two up. And just down here real quick. This adds up to 1. It always should. Right? Adding up all the probabilities should add up to 100%. And adding these up gives me a negative 500 over 1,000. So my expected value, meaning if I play this game, 10,000 times, 100,000 times, what do I expect to have at the end of all of it? Is going to be, I'm going to be down 50 cents. Meaning I'm going to lose quite a few times, and then every once in a while I'll win. And so it kind of balances it out. So that's our answer here. Next up, number 5. So the prizes that can be won in the sweepstakes are listed below together with the chances of winning each one. So we have $4,200. There's 1 chance in 8,000 that you'll win. $1,600, 1 chance in 6,900. $500, 1 chance in 3,300, and $300. There's 1 chance in 2,000. Find the expected value. Now this is different than the previous one. Find the expected value of the amount won for 1 entry if the cost of entering is 53 cents. So we're going to find how much we're going to win with all these probabilities. And then at the end, we're going to subtract off the 53 cents because that's what it cost us to enter. So I have to do this. 4,200 times 1 over 8,000 plus 1,600 times 1 over 6,900 plus 500 times 1 over 3,300, 500, plus 300 times 1 over 2,000. And then after we get all that, we're going to subtract off 53 cents to see what we get. This gets a little tricky. Got to be real careful. I actually made a mistake on it the first time I went through it. 4,200 times 1 divided by 8,000. Notice I'm using my parentheses. Plus 500 times 1 divided by 3,300 plus 300 times 1 divided by 2,000. That gives me that much, but then I have to subtract off the 53 cents, minus 0.53. And if I round this off, I would have won 53 cents. It happens to be the same number as the amount that it cost when we round it off. So that 8 brings that 2 to a 3. Number 6. And then make sure we're okay there. Push that up. All right. And we will definitely need our calculator for this one. They're giving us that n is 4. X is equal to 3. And P is 1 over 6. Now, for this one, we're going to use a distribution. Push that up a little. Distribution. So I hit second in distribution, and this is a binomial distribution. We have a greater than or less than. So we're going to use PDF for this one. And the number of trials, by the way, you may have a different interface, and I'll show you what that interface will look like here in just a second. The number of trials is 4. The probability is 1 divided by 6, and I can just put the 1 divided by 6 right in there. X is 3. Now, if you don't have this, if you have a TI 83 or an older 84, it won't look like this. It's going to be like this. You'll literally, it'll say this, you use the commas. Make sure you can see the commas. Commas are right here. And that's how you'll put that in. And so our answer becomes, so this is binom PDF PDF 4 1/6 and 3. That is approximately 0.0154. So that's how you use that. So let's move on to number 7. Number 7. Number 7 says, a test consists of 10 true-false questions. To pass the test, a student must answer at least 6 questions correctly. If the student guesses on each one, and the guesses tells us that means that the probability is 0.5. What is the probability that the student will pass the test? So in this case, we have that n is 10, p is 0.5, x is bigger than or equal to 6. Now, I want to write this out carefully. Our calculator only knows how to do less than. Here we have a greater than, so we're going to have to compensate a little bit. Let me show you what we're going to do with that. Let me write this out for a second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's our n equals 10. So all of our probabilities together is he could get none right. He'd get 1 right, 2 right, 3 right, 4 right, 5 right, 6 right, 7, 8, 9, or 10. Now, what the problem wants to know is bigger than or equal to 6. But your calculator only knows how to do less than. So we're going to have to do that and trick it. Let me show you what I mean by that. I'm going to do 1 minus binom And this is now CDF because we have a greater than or less than. N is 10, P is 0.5. And I now want to do 5 and below. I'll show you what that looks like. 1 minus distribution, binom CDF in this case because of the inequality, 10.5. Notice I don't use commas when I have this interface here. I only use it if I don't have this interface. And 5. That's going to give us number 7. And does it say where to round it off? What does it say? It says 3 decimal places in the directions. Oh, it said that for the previous one as well. I went to 4. So 0.377. So this previous answer here would be 0.015. And let's see if we can squeeze 8 into here. In a certain college, 33% of the physics majors belong to ethnic minorities. And 6 belong to an ethnic minority. So in this case, N once again is 10. P is 0.33. X is no more than 6. That means X is less than or equal to 6. So because it's less than, I don't need to do the 1 minus. So this is just binom CDF, because the inequality again. N is 10, P is 0.33, and X in this case is 6. Ten 0.33 and 6. Zero 0.98, 3 decimal places, so 81. Number 9. In a study, 44% of adults questioned reported that their health was excellent. A researcher wishes to study the health of people living close. Find the probability that when 14 adults were randomly selected, 3 or fewer were in excellent health. Right? In this case, N is 14. P is 0.44. X is less than or equal to 3. So it says 3 or fewer. So this is regular binom because it's less than. And because it's less than, I don't have to do the 1 minus in this case. All right, so distribution. Binomial CDF. N is 14, P is 0.44, X is 3. This one's also 3 decimal places. That's how it's done. All right, number 10. In a survey of 300 college graduates are randomly selected without replacement for a follow-up survey, what is the probability that 3 of them entered the profession closely related to their major. So this one's going to be a little bit different than some of the others. In this case, we have that n is 8. P is 0.56. And x in this case is exactly 3, so equals 3. So we're going to use the binom PDF in this case. We use PDF when it's equals. We use CDF when it's bigger than or less than. I know I sound like a broken record, but that's one of the most common questions we get, so I'm just going to repeat it over and over again. All right, so here we go. Distribution. PDF in this case, 8.56, 3. And this doesn't say word rounded off, and my default is always to 4 decimal places, if you're ever not sure. 0.1622. A tennis player makes a successful first serve 51% of the time. If she serves 9 times, what is the probability that she gets exactly 3 serves in? So it's looking to me that we have n equals 9. P is 0.51. And x is exactly 3. So again, we're going to be using PDF again. So second distribution. PDF in this case, because it's equal to. And here we have 9.51 and 3. And I got this. So again, make sure you're trying it with your calculator. If you need to pause it if I'm going too fast, then just pause the video. That's fine. Number 12. Only one of which is correct. If Judy, who forgot to study for the test, guesses on all questions, what is the probability that she will answer exactly 3 questions correctly? Okay, this one's a little, we're going to do some thinking here. N is 12. Now, P is a 1 in 5 chance, which is 0.2. And if you want, you can just directly put into the calculator the 1 divided by 5. That's fine too. X is exactly 3 again. So because it's an equals, we're going to use the PDF again. Binom. PDF. 12.2 and 3. And that's going to get us, so second distribution. Oh, hit the wrong button. There we go. Scroll down. Binom PDF again. Trials is 12. Pete, watch, I can put directly 1 divided by 5, in case you didn't want to calculate that. X is 3 again. Paste. Paste. All right, number 13. According to a college survey, 22% of students work full-time. Find the mean for the number of students who work full-time in samples of size 16. We're going to use this formula here, n times p. And in this case, n is 16, p is 0.22. Let's see if I can squeeze 14 here. I'm going to change colors because my black pen is dying. Let's do a fun purple. All right, next up, we have the probability the person has immunity to a particular disease is 0.2. So that's going to be my p is 0.2. And in this case is 30. So my mean is 30 times 0.2. 30 times 0.2. Not too difficult. 15. Let's make sure I'm staying on the page there. 15. In a certain town, 20% of voters are in favor of a given ballot measure and 80% are opposed. For groups of 120 voters, find the mean for the number of who oppose the measure. So they give us 2% here, and we need to only use the one that's for the opposed. So P in this case is 0.2, that's 20%. And N in this case is 120. Oh, I'm sorry. 0.8 are opposed. See, even I read it wrong, just be careful. And N is 120. So our mean in this case is 120 times 0.8. That's 96, but we'll say 120 times 0.8. 96 are opposed. Number 16 is a little different. 16, 17, 18 are just a little different. Let me scooch this up a little. Yeah, actually that's funny high. 16. According to a college survey, 22% of the students work full-time. So there's my P. Find the standard deviation for the number of students who work full-time in samples of size n equals 16. Now, for the standard deviation, we need 3 components, and the formula is written in 2 different ways. N times P times 1 minus P. And sometimes it's written as N times P times Q, where Q is 1 minus P. I tend to use Q, so if you see me ever put the Q, that means the complement of P, 1 minus P. So in this case, Q is 1 minus 0.22. It's 0.78. So my standard deviation for this group is the square root of 16 times 0.22 times 0.78. Your calculator, you may need to use more parentheses and stuff. Times 0.22 times 0.78. And they don't say where to round it off, so again, I'll go 4 decimal places. 1.657. I'll go 3 decimal places. A little less messy that way. So there we are. Standard deviation. 17. On a multiple choice test with 29 questions, that's my N. Each question has 4 possible answers. That means that P is 1 out of 4, or 0.25. One of which is correct. For students who guess at all answers, find the standard deviation of the number of correct answers. So I can see that Q, which is 1 minus P, is going to be 1 minus 0.25, which is 0.75. Which means my standard deviation is going to be the square root of 29 times 0.25 times 0.75. Let's try it here. Square root of 29 times 0.25 times 0.75. 2.3318. And number 18, I'm going to try squeezing down here. A company manufactures batteries in batches of 28, and it's 28 in this case. And there is a 3% rate of defects. Find the variance for the number of defects per batch. Now, variance is just our standard deviation without the square root. So our P in this case is 0.03, that's 3%. Our Q in this case is going to be 1 minus 0.03, which is 0.97. So our variance, which is our standard deviation squared, is going to be N times P times Q, which in this case is 28 times 0.03 times 0.97. So no square root in this case, 28 times 0.03 times 0.97. And there is our variance. Remember, no square root for this one. So we're looking for variance. 2 last questions. Here. Number 19. So usual and unusual, again, we're going out a couple of standard deviations out. We talked about that earlier. The Acme Candy Company claims that 60% of the job breakers it produces weigh more than 0.4 ounces. Suppose that 800 job breakers are selected at random from the production lines. Would it be unusual for this sample of 800 to contain 399 job breakers? Okay. What we need to find for this is we need to find the mean, which in this case is going to be N times P. For this problem, N is 800, P is 0.6, and Q, which is our 1 minus P, is 0.4. So to find the mean, I'm going to go N times P, that's 800, times 0.6. That's 480. I'm also going to need the standard deviation because I have to go 2 standard deviations above and below to see what usual is. So our standard deviation if you're 0.6 times 0.4. By the way, this 0.4 has nothing to do with the 0.4 that's in the problem. It has nothing to do with the 0.4 ounces. It's just a complement of the probability. So I'm going to go square root 800 times 0.6 times 0.4. Make sure you might need to use parentheses with your calculator. This is going to give me a funky number. Now I'm going to use my memories here. Let me show you what I mean by that. I'm going to store this number as the letter A in this case. So alpha, because it's green, alpha A. And that way I get all those digits. I don't have to do any rounding or anything like that. So I can get it as accurate as I can. And watch what I can do with this now. I'm going to go mu minus 2 sigma and mu plus 2 sigma. And if you remember, I stored this number. This is was about 13.856. And I stored that into allotment A, memory allotment A. Now, I'm not going to type that in. I'm just going to use the letter A that I put in there. So for this one, I'm going to go 800. I'm sorry, the mean, which is 480. Times A. And we got to hit the alpha button first. So our lower boundary is about 452. I'll round it off to the nearest whole. Versus this one, which is 480 plus 2 times A. Again, A being this number here. So 480 plus 2 times A. We'll say 508. So as long as we are between 452 and 508, and here in the middle, we have the mean, which is the 480. So this is 2 standard deviations away. And as long as we're here, it's considered usual. Out above here or less than here, it's considered unusual. And the question that they ask us specifically is, would it be unusual for this sample of 800 to contain 399 jawbreakers that weigh more than 0.4 ounces? Now we can see that 399 is well below my lower boundary here, my 2 standard deviations down. So the answer is unusual. There it is. Number 20, it's very similar. Let's scooch that up. All right, a survey for brand recognition is done, and it is determined that 68% of consumers, that's going to be my P, have heard of Dull Computer Company. A survey of 800 randomly selected consumers, there's my N, is to be conducted. For such groups of 800, would it be unusual to get 530 consumers who recognize the Dull Computer Company name? So I'd like to point out very quickly that Q in this case is going to be 1 minus 0.68, so 0.32. Our mean is going to be N times P again, 800 times 0.68. 800 times 0.68. 544 in our standard deviation can be the square root of 800 times 0.68 times 0.32. So we do square root of 800 times 0.68 times 0.32. And like I did before, I'm going to store that. And just to make sure we remember how to do that, I'm going to go here and I'm going to store into alpha A. And I like writing down where I store it because sometimes you'll have 3 or 4 or 5 memories and it's good to know what's where. and make sure you don't overwrite something. Now, if you remember the previous problem, I used A as well. When I just stored that into A, what it did was it erased the old A and put in my new A. It does it automatically for you. So if you wanted to keep something in one, you may want to use B or C or D or whatever. All right, so here we go. And again, I'm going to round these off to whole numbers. So we'll say 518. And 570. And the question wants to know, would it be unusual to get 530 consumers who recognize the Dell Computer Company name? And the answer is no, it's not unusual, because 530 is well within our boundaries here, within 2 standard deviations. So no, 530 is not unusual. That's it. I hope that helps.